Hello everyone and welcome back to my channel. Today I'll just be going over some of the first images that were released from the James Webb telescope and how they're going to impact future astrophysical research in the field. So the first image we have here is of the Carina Nebula, and this may be familiar to you as we know that Hubble has also taken a picture of this nebula. But what's really interesting is how the James Webb telescope is able to peer into the gas clouds of the Carina Nebula, something that Hubble was never able to do. And we see these numerous stars that are being formed in this star birthing region that we could never see with the Hubble Space Telescope. Something else that's also interesting with the James Webb Telescope is this sense of dimensionality in all the images. So you notice how we can see that this is kind of further back into the image than all this foreground here. And another thing to also note is kind of the scale at which James Webb takes these images, because we noted that before the Hubble image was only a fraction of the size of the image, which shows the power of the new magnification of the James Webb telescope. So next we have a really famous image that's been released from the James Webb, which is Stephan's Quintet, which is this group of 5 galaxies in this area of space, which reveals very, very crucial details about galaxy evolution and the processes that shape the way that galaxies move around through the universe and interact. Something that's to be noted is how the James Webb Space Telescope can look into the individual star systems in these galaxies, as we can see these tiny little dots that are scattered throughout each galaxy, showing again the depth and complexity at which the James Webb Telescope reveals details about our spacetime. Finally, what's also to be noted is how we can also see the galaxies smashing into each other, which furthers and shows us how the galaxies evolve over time, over billions of years in spacetime. Now here we have the Southern Ring Nebula, which before, as seen by Hubble, we could only see again the gas on the outside, but now with the James Webb Telescope we can peer through the gas and see the star inside. This is actually a misconception, as we thought it was a star, but now with the James Webb Telescope we can see that it's actually a binary star system. And what's also interesting is how one star is fully clear, as we can see with the blue light, but the other cloud is totally covered with dust with the red glow, as we see on the left side here. And so what is really interesting about this image is that the James Webb can also give insight into which gas molecules are emitted by stars throughout their evolution period, and how these gas clouds evolve over time as the star evolves through its stages of its lifetime. So that's one of the other big impacts that the James Webb Telescope will have. Now here we see an atmosphere composition, which is something different that we couldn't really see in Hubble, of a planet called WASP 96b, which is a hot gas giant exoplanet far away from Earth, many thousands of light years away. What's interesting about this image is how the James Webb Telescope can look and peer into the different levels of water throughout the atmosphere at different depths of the atmosphere, which is way more detailed than anything that the Hubble Space Telescope could do. Because with Hubble, all we knew was, well, there is water on this planet, but with the James Webb, we now know what state is the water in, where in the planet is this water, and how is it transforming, how is it evolving, how does the water cycle work on these planets. So the biggest impact of this that will impact future astrophysical observations is it will give us a key insight into which types of exoplanets reflect Earth's atmosphere, which is really interesting and helps us find potentially new alien life on other planets. Finally, we have possibly the most astonishing image taken by the James Webb Space Telescope, which is the SMACS Deep Field image, which shows galaxies ranging from around 5 billion light years old to 13 billion light years old, which is the oldest images of galaxies that we've seen. So if you see here, you see these red-shifted galaxies here and here. What we noticed about them is that they're literally 13.1 billion years old, almost as old as the observable universe itself. Now, what is also astonishing about this image is that if you were to hold your arm out onto the night sky and imagine a grain of sand, that's actually how big this image is. So if you imagine that grain of sand in the sky, and if you were to zoom into that grain of sand, then you'd see this whole image. So again, this reveals how powerful, how much more powerful the James Webb Space Telescope is than the Hubble Space Telescope. And even more astonishing, even more breathtaking, is how each of these individual dots that you see on the screen is a galaxy in and of itself. So this is one of the greatest impacts of the James Webb Telescope in revealing the formation and the evolution of the universe. Where did this all come from, and where are we going? And it's just amazing how technology continues to evolve, and it's also very exciting to know how the field of astrophysics will continue to evolve in the future. Thank you very much, and I hope to see you next time.